Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The pKa of an alcohol measures its acidity. A lower pKa means a stronger acid, which means the OH bond donates a proton more readily. Electron withdrawing groups, EWGs, stabilize the conjugate base, alkoxide ion, by dispersing negative charge through inductive effects, thereby increasing acidity and lowering pKa. Moving on to the next step. A. Ethanol, CH3CH2 of no EWG, baseline alcohol acidity, pKa 15.9. B. 1-propanol, CH3CH2CH2 of no EWG, slightly more electron-donating alkyl chain than ethanol, similar or slightly higher pKa, 16.1. C. 2,2,2-trifluoroethanol, CF3CH2 of 3 fluorine atoms on the carbon adjacent to CH2O. Fluorine is the most electronegative element, and 3 fluorines exert a very strong inductive electron withdrawing effect, strongly stabilizing the alkoxide conjugate base, pKa 12.4. D. 2-chloroethanol, ClCH2CH2 of 1 chlorine atom to carbons away from O. Chlorine is EWG but less electronegative than fluorine, and only one halogen is present, pKa 14.3. Moving on to the next step. Rank acidity, lowest pKa is equal to most acidic. 2,2,2-trifluoroethanol to chloroethanol, ethanol 1-propanol. And for the final step. Ethanol and 1-propanol have only electron-donating alkyl groups, making them weaker acids, higher pKa. 2-chloroethanol has only one EWG, Cl, and it is 1 carbon further from O compared to CF3CH2O, so stabilization of the alkoxide is much less. 2,2,2-trifluoroethanol has 3 highly electronegative fluorines directly on the carbon bearing the O group, providing the maximum inductive stabilization of the conjugate base among all options. Therefore, the correct answer is C. Therefore, the correct answer is option C.